In this video, I'm going to be explaining geometric series and how to write and solve them. Okay, the geometric series is basically finding the sum of a geometric sequence. So you take a geometric sequence and you add up all the terms, and that is actually how you would find the geometric series. So for example, we know that this is a sequence. This is a series of a sequence because you're multiplying every term by 2. 2 times 2, 4 times 2, 8 times 2, and so on. If it is a summation notation, it would look like the form of this, to where you would have a term that is raised to a power. The exponent is the variable, and so you know that is 9 times out of 10 going to be a geometric series. So here's the formula. I'm going to move myself over here, excuse me. So a geometric series formula is the first term times this giant parentheses of 1 minus r to the n on top. N represents the number of terms if you want the first 10 terms, if you want the first 100 terms. And then on the r for the top and the numerator and the denominator, it is the ratio. So find the sum of the first 12 terms of the arithmetic sequence. So we know that it is the first term times 1 minus r to the n over 1 minus r. Now, please don't confuse this r to the n with the sequence, because the geometric sequence has r raised to the n minus 1. The geometric series is different. It is just r raised to the n. So first thing we need to do is we need to find our first term. Well, they gave it to us, which is great. Is 2 over 25. Now, on the inside, we need to figure out r. Well, we need to figure out what multiplies to get from 2 over 25 to 2/5. I don't know. It depends. Fractions aren't necessarily fun sometimes of figuring out what multiplies to get to the next fraction. So if you can go to another term, that makes it easier. Like, I don't know, maybe what multiplies by 2 to get 10? Well, it's going to be 5. And so is every term 5? Yes. 2/5 times 5, the 5's cancel, leaving you 2. 2 over 25 times 5, it reduces by 5, which is why I get 2/5. So we know that r is 5, which means on bottom we can write r is 5. And we are looking for how many terms? The first 12 terms. So here's where you have to be very careful in the calculator. So in the calculator, what I would do is 2 divided by 25, close the parentheses, new parentheses. Now, I need to do just the numerator. Like, the numerator needs to stay together and the denominator needs to stay together. So I'm going to create a new parentheses for just the numerator. Divide that by the parentheses that is just the denominator. So see here inside, numerator, denominator, and then I'm going to close the big parentheses. So if you were to do that, you would get 2 divided by 25, open the parentheses, new parentheses, divided by basically -4, and you will get 4882812.48, which is a very big number, which will make sense because every number keeps getting 5 times as large as the previous number. So you are going to get many, many big numbers sometimes in a geometric series. Here's a summation notation with sigma. So I know that this is a geometric series because the variable is the exponent. So we know the formula is the first term, which, how do you find the first term? You plug in 1. So the first term is 3 times 0.4 to the 1. Well, 3 times 0.4 is 1.2. So I know my first term is 1.2. I know my ratio, it is the number that is raised to the exponent, so it's 0.4. And it's asking for the first 10 terms, and on bottom it's also 1 minus 0.4. So you put it in a calculator, 1.2 times 1 minus 0.4 raised to the 10th divided by 1 minus 0.4. And you will get the answer of 1.1998, depending on where you need to round. Divide. Please don't forget to make sure you put an additional parentheses around the numerator an additional parentheses around the denominator. Now, there is one other thing I want to talk about in geometric series, and that is an infinite geometric series. All right, an infinite geometric series is when the common ratio has a property of the absolute value that's less than 1, meaning it has to be between -1 and 1. Because it could be negative, but the fact that it has to be less than 1, the sequence actually eventually will approach 0. It doesn't ever hit 0, but it approaches very, very close to 0. So for example, if this geometric sequence is multiplied by 1/5 every time, 5 times 1/5 is 1, 1 times 1/5 is 0.2, 0.4, 0.008. If you notice, this number is getting tiny. Very, 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 very small. So if you think about you doing this 100 out, you're going to have 0.00000000 forever. It doesn't actually hit 0, but it's very, very close. It actually what we call converging to 0. And when that happens, something nice actually happens. So for example, this is another one. This is a geometric sequence, or this is geometric because you have the variable as the exponent, and the number that is raised to that variable is always going to be your ratio. And obviously we can find the first term by plugging in 1. But if you notice, this has an infinity sign, meaning it is an infinite geometric series. They want to know if you were to add up all the terms, if you were to take all of these terms and add them up, eventually all these numbers way out to where there's like 0.00000000000, you keep going with the zeros. Those numbers are so small and insignificant, it doesn't even affect these numbers that are basically the biggest in the front. So here's what happens with an infinite geometric series. It actually converges to a different formula. You have the first term divided by 1 minus the ratio. And here's why. The normal term, or a normal formula, is this. However, this number right here gets so small because remember, this only works when r is less than 1, meaning it has to be between 0 and 1, the absolute value of it. So if you have if r is 1/2, if r is 1/3, when you have really, really large numbers for n, like you're wanting to know the 1,000th term or the 1,000,000th term, it gets tiny. 1/2 raised to the 1,000th term has so many zeros in the decimals, like it's not even funny. Which means this actually goes basically is approaching 0. It's so insignificant it doesn't matter. So you're left with the 1 on top and then just the 1 minus r on bottom, which is actually how you get this. The first term times the numerator is actually just how you get the first term, and this divided by 1 minus r. So to find this, because it has the dots, it means it keeps going on forever. What is the ratio? You're going 8. Looks like it is going by halves, but it's going by a -1/2. 8 times the -1/2 is -4. -4 times the -1/2 is a +2 because negative times a negative. So every other term becomes positive, positive, negative, positive, negative. Because the dot, 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 it wants to know the sum of going on forever, which means you're going to use the infinite geometric series formula. You know the first term, it is 8. You know r, it is -1/2. So basically you have 8 divided by 1 plus a half. So you have 8 divided by 1 plus a half, and your answer is 5.333 repeating, basically. And that's your answer. There's nothing else you have to do.